On today's show, we review linear functions for our test next week. Hopefully you find this video helpful to review what you worked on in class today on Friday. So number one asked us, which graph shows a line where each value of y is 3 more than half of x? So I need a line where y is, so y equals 3 more than half of x. Well, that's half of x, and that's 3 more than it. So I need to figure out which line is the graph of y equals 1/2 x plus 3. So I know this line has a y-intercept of 3. So I know I cross the y-axis at a value of 3. Choice 1 does not have a y-intercept of 3. Choice 3 does, choice 2 does, and choice 4 does. So all of those are possible options because they have a y-intercept of 3. My slope is 1/2. My slope is 1/2. That tells me how my line changes. The change in y over the change in x. As x goes up by 2, y goes up by 1. This is an increasing line because it has a positive slope, so we can get rid of choice 4 because that line decreases as we read left to right. So we're stuck between choices 3 and choice 2. This line has a slope of up 2 over 1. That is a slope of 2 over 1, whereas this line has a slope of 2 over 4. 2 over 4 is 1/2. So choice 2 is the answer because it has a slope of 1/2 and a y-intercept of 3. Make sure you can write equations of lines and make sure you can identify slopes and y-intercepts from graphs. Number 2, which table of values represents a linear relationship? The key thing that makes you linear is that constant average rate of change. You need a constant average rate of change. That means it doesn't matter what 2 points I find the average rate of change between, it better be the same number. So we look at function 1 here. How do I get from -3 to -2? Think about a number line. I add 1. How do I get from -2 to 1? I add 3. I add 5. And I add 7. So this doesn't look promising, but we still need to look at our change in x. Plus 1, plus 1, plus 1, plus 1. So these are my change in y's, these are my change in x. Is it linear? No, because 1 over 1 is not 3 over 1. They're not the same. I don't have that constant average rate of change. I'm not adding the same number each time I go up by 1. So f is not linear. Let's look at 2. Well, 2 looks like it has a pattern. We'll talk about that pattern in a minute. Am I adding the same number each time? I'm not even going to look at that fraction, because I don't like fractions. Plus 1, plus 2, plus 4. That's a change in 1, that's a change in 1, that's a change in 1. Just because these two average rates of change are not constant, I know this is not linear, because 1 over 1 is not 2 over 1. The slope is not the same. I'm not adding the same number each time. Linear relationships add the same number each time. This is multiplying by the same number each time. We're multiplying by 2. Multiplying does not have to do with linear functions. That has to deal with functions we'll look at in the future. Linear functions, we add or subtract the same thing each time we increase x by 1. That's a plus 2. That's a plus 2. That's a plus 2. This looks promising. That looks like a plus 2. Plus 1, plus 1, plus 1, plus 1. So number 3 looks like it has that constant average rate of change. It has an average rate of change of 2 over 1, which is better known as 2. So the slope of the line for f of x is 2. We could write its equation because the y-intercept is right there. The y-intercept is when x equals 0. Y equals 2x minus 1. However, that's not entirely correct because they call the outputs f of x. So we should call the outputs f of x equals 2x minus 1. If we look at choice 4, we're not going to have that constant average rate of change we desire. Number 3, which inequality is represented in the graph below? So looking at this inequality, I can tell 2 things immediately. I'm shading above. See how we're shading above this line? I'm shading up. If I go to a point on the line and go up, I'm in the solution set. So this is a greater than inequality, and the line is solid. This is a solid line, so I include the equal to. Let's see if I can get any choices knowing those two things, knowing it's a greater than or equal to inequality. 2 and 4 are gone because those would be shading below, and shading below is not in the solution set, it's not on the graph. So we're stuck between choices 1 and 3. Do I have a y-intercept of 4, or do I have a y-intercept of -3? My y-intercept is 4, so it's choice 1. Choice 1 is the solution because it's greater than or equal to, and I have a y-intercept of +4. Rachel and Mark were given information shown below about the bacteria growing in a petri dish in their biology class. Rachel wants to model this information with a linear function. Okay, I know stuff about linear functions. Mark wants to use a nonlinear function. Which model is a better choice? Well, what makes me a linear function is that constant average rate of change. Do I have a constant average rate of change? Average rate of change. I forgot the word rate. It's a constant average rate of change. So let's look at the rate of change. I notice that x is going up by 1, so I'm going to look at my change in y. Plus 60, plus 70, plus 90. This does not look promising. That's plus 101. That's plus 140. This is not a constant rate. This is not growing at a constant rate. So Mark wants to use a nonlinear one. Let's go with Mark. The nonlinear function, because, why do I go with the nonlinear function? Because the average rate of change, is not constant. So I know if a function is linear if it has that constant average rate of change. Clearly here my change in y over my change in x, which was always 1, so I really need to look at my change in y, was not the same number each time. This function's not growing linearly. It's growing at some other model that would be more appropriate. So let's not use a linear function here because that average rate of change does not exist. The average rate of change exists, but it's not constant. Number 5, on the set of axes below, graph this inequality. Well, I do not like the way this inequality looks because it's not in slope-intercept form. So let's get it into slope-intercept form. Let's move over the 4x, move over the 4x. Minus 2y is greater than 2 minus 4x. Now I don't like the way that looks because that's not really slope-intercept form, so I'm going to change the order there. Divide by -2. And I'm currently dividing by a negative number in an inequality, so that warning light is going off in my head. Warning, 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 that I need to flip the sign. I get 2x minus 1. So I need to graph that line. That inequality, I need to graph the solution set of this inequality. Y is less than 2x minus 1. I notice that there's no equal to, so I know I need a dashed line. Because the line, that border line, is not in the solution set. Well, how do I graph that line? It has a slope of -1. It has a y-intercept of -1 and a slope of 2. So I go up 2, right 1, up 2, right 1. Now plot these points. Let's start over because that was a mess. Had dots everywhere. Up 2, right 1, up 2, right 1. Let me go the other way. It makes sense that this line would be increasing because it has a positive slope. And I have a dashed line. It's not a solid line because the border is not part of the solution set. That's very, very, very important. The other part is to determine which half plane I am. Am I in the lower half plane or am I in the upper half plane? Well, I know y is less than. I look at this inequality here. Y is less than. So I need to shade below. Here's a point. I need to go down. Go down from any point on the graph, and you see that you're in this lower half plane down here. So any point in this half plane is a solution. This point here is a solution. That point there is a solution. But if I'm not in that half plane, I'm not a solution. The next question asked, is the point 0, -1 in the solution set of the inequality? Well, where is 0, -1? There it is. Is that black point, let me change its color, is that purple point in the solution set? Well, explain your reasoning based on the graph. So there's two ways you could do this. You could take that point and plug it in, but that's not based off the graph. Based off the graph means I have to look at the graph and explain my reasoning using the graph that I just constructed. The answer is no, it's not, because it's on a dashed line. No, 0, 1, -1 is on the borderline, which is dashed. The line being dashed means it's not in the solution set. This means points on the line are not in the solution set. You could also do this algebraically, but you wouldn't get full credit because it said based on the graph by plugging it in. So your solution set is the graph. When we graph things, we're graphing the solution set. Number 6, Sue and Kathy were doing their algebra homework, like all good Algebra 1 students do. They were asked to write the equation of the line that passes through those points. Sue wrote that equation and Kathy wrote that equation. Justify why both students are correct. Well, let's pretend like I don't know Sue and Kathy's equations here. There's many, many ways to answer this question. One way is to take both those points and plug it into both. Do 4 checks there. That's one way to do it. Well, I'm going to pretend like I don't see their equations and find the slope. Slope is change in y, subtract your y's over change in x. It's your change in y over your change in x. So I have 6. 6 is not a y value. Y value is change in y. 4 minus 1 over, what goes with 4? -3 minus 6. So this has a slope of 3 over -9. 3 over -9 is better known as -1/3. So my equation, Kathy and Sue's equation, should have a slope of -1/3. Do they? Kathy's does. And this is kind of in point slope form. Sue's does. So they both have the right slope. Now I can check the y-intercept multiple ways. I'm going to take Sue's line. I'm going to take Sue's line here and add 4 to both sides to get it into point slope form. We know this does. This line definitely passes through this point and that point because it has a slope of -1/3 and passes through the point -3, 4. What about that line? Well, let's see if these lines are actually the same. Distribute that in. -1 plus 4. Y equals -1/3 x. -1/3 x plus 3. That's Kathy's line there. So we showed that Sue's line was correct. We know that Sue's line is correct from point slope form. And then we distributed to get Kathy's line. This is just one way to answer the question. The probably most straightforward way is to take these points and plug them into both of them and see if they're solutions, see if they work. And they do, because both of those lines do pass through those points. That's probably the most straightforward way. But I wanted to go through slope and go over point slope form again with you. Number 7, a typical cell phone plan has a fixed base fee. That sounds like a y-intercept. That sounds like a y-intercept type thing. And a certain amount of data for an overage charge. And a certain amount of data. And an overage charge for data used beyond the plan. So you have some fee that you pay up front and then an overage fee. A cell phone plan charges $62 and an overage charge of $30 per gigabyte. That per gigabyte there tells me that is the slope. I know immediately that $30 per gigabyte is the slope if I exceed 2 gigabytes. Let C represent the cost and G represent the total number of gigabytes of data. Which equation represents this plan when more than 2 gigabytes are used? I know I have a slope of 30. These are in point slope form here. This value is your slope because it's next to the g. This is kind of the y value that it passes through. So I know choices 1 and 2 are gone because I need a slope of 30. The slope of my line has to be 30. And when I use 2 gigabytes of data, that cost me $62, which is why it's choice 4. This was a tricky question, which is why it got rejected and not put on the test. The key takeaway from this is slope is a reoccurring, it happens every time. This $30 per gigabyte. Keywords are per, each, every. Those are keywords for the slope. The y-intercept is a one-time fee, a fixed cost, something that you pay once and then you're done, which is kind of what this $62 is representing. Regardless of how much data I use, I have to pay that $62. So on your test, it will not be as challenging as this question was, but you still need to have that idea of recognizing slope and recognizing a fixed rate. And finally, number 8, the function t of x is shown in the table below. Great, it's a lovely function. Explain why t is linear. I know how to do that. What makes something linear? A constant average rate of change. So hopefully we can show that t has a constant average rate of change. Let's find our change in y. That's negative 2.5, negative 2.5, negative 2.5, negative 2.5. Okay, my change in y's are the same. Well, what's my change in x? Plus 2, plus 2. How do I get from negative 1 to 1? Plus 2, plus 2. This looks promising because my change in y over my change in x always is negative 2.5 over 2, which is better known as negative 1.25, or if you like fractions, negative 5/4. That's my slope. It has that constant average rate of change. I see the word explain, so I should have some sentence saying t is linear because it has a constant average rate of change. Write an equation for t of x. Well, I have the slope. I know the slope is negative 5/4 or negative 1.25, your choice. So I need the y-intercept. I don't have it because I don't know when x equals 0. So let's use point slope form. Let's shift over to a point. Let's shift over to a point. So I have y equals negative 5/4 times what? Let's use the 0.15. You could have picked any point you wanted to here. X minus 1. Remember, the implied shift is opposite, plus 5. This is almost right, but they said write an equation for t of x. Use the variables they give you. So t of x equals negative 5/4 x minus 1 plus 5. And you could have picked any point. Your equation could have been t of x equals negative 5/4 x plus 3, and shifting left 3, plus 10. That's the same equation if you distribute both of those out. The bell just rang for 6th period, which means I am done. Have fun studying this weekend.